All right, so we say that this has a period of pi. So it's just a little bit shorter than, than sine or cosine is, okay? So we have those vertical asymptotes, and like I said, it repeats just like sine and cosine. So that's why we call it periodic or cyclic. It means the same thing, okay? This time, notice though, the answers occur again, the same values for the y occur every pi. So that's why in this function, we're adding pi instead of adding 2 pi, and that's just because the period. Okay. Transformations are exactly the same. Absolutely nothing has changed here except I fixed my typos. A is still going to reflect over the x-axis. If it's negative, it's still going to stretch or shrink vertically. B is still going to stretch or shrink horizontally. Horizontal shifts are going to happen with the H. Left is plus, right is minus, and vertical shift up and down is still going to be that K. Okay, nothing has changed except the original picture. All right, so we're going to fill in the values for the original tan, and then we're going to change them based on whatever the A, B, H, and K are. Okay. Basically, the notes look almost identical. The only thing is that I changed the word to tan. Okay. So we have, let's see. So we're going to start at negative pi over 2. And then a full period would end pi later. So if I add pi to that, that's going to give me positive pi over 2. Halfway between is going to be 0. And then halfway between each of those will be negative pi over 4 and pi over 4. That way I'm nice and balanced here. Okay. So if I take tan of negative pi over 2, remember where we are on the unit circle, right? Negative pi over 2 is down here. Cosine, comma, sine, and that's 0.0, negative 1. So if I do sine over cosine, right, because tangent is sine over cosine, I'm going to get undefined. Okay. If I do positive pi over 2, I'm going to have the 0.0, comma 1, and sine over cosine, again, is undefined. If I use 0, that's going to give me 1, comma 0, so I will get 0 when I do sine over cosine. And pi over 4, that's root 2 over 2, root 2 over 2. If I do sine over cosine, that's something over itself, so I'm going to get 1. If I do pi over 4, if I do positive pi over 4, is 1. If I do negative pi over 4, which is down here, it's going to be the same thing. It's just the y value is now a minus. So when I go to do this, that sign is negative root 2 over 2 over root 2 over 2, so I get negative 1. Okay, so that's the pattern we're going to see every time. So negative pi over 2 is undefined. That's going to be my dashed line. Negative pi over 4, negative 1, 0, 0. Pi over 4, 1. And pi over 2 is another asymptote. And then it almost has like a cubic feel to it. All right, so the next question is throwing a negative in there. The negative is going to give us a reflection over the x-axis, which means that every y value is just going to change sign. So your y values are just changing sign, S-I-G-N. Otherwise, it's exactly the same. So I still have the same x values. Undefined is still undefined, but negative 1 becomes positive, and positive 1 becomes negative. So these asymptotes have not changed. It's just the negatives became positive and the positives became negative. Kind of like a cubic. Looks very similar to a cubic function. Okay. All right, so next one, vertical stretch. All right, so we have negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2, and that's undefined, negative 1, 0, 1, undefined. All right, so 2 times the tangent. So what that is a vertical stretch. We're multiplying the y values by 2, okay? We're going to multiply y values by 2. So the x's are staying exactly the same. Nothing is changing there. and the y column gets multiplied by 2. Now, undefined is still undefined. Nothing is going to change there. Negative 1 times 2 is negative 2, 0 times 2, and 1 times 2. But undefined is still undefined. Okay. And then very similarly with the 3, we are going to multiply the y value by 3 instead of 2 this time. So other than that, x is staying exactly the same. It's just a vertical stretch. So undefined is still undefined. Negative 1 times 3, 0 times 3, and 1 times 3. And see how it's stretched. Okay. All right. Vertical shrink, exact same concept here. So we have negative pi over 2, pi over 4, negative 0, positive pi over 4, pi over 2, undefined, negative 1, 0, 1, undefined. Okay. All right, so the 1/2, same idea. We're just going to multiply the y value by 1/2. So the x's stay exactly the same. And we multiply by 1/2. Remember, undefined is still undefined. So that's negative 1/2, 0, 1/2. Negative 1/2, 0, 1/2. And the undefined is still undefined. All right, exactly the same concept. It's just times 1/3 this time. So we still have negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Undefined doesn't change. That's negative 1/3, 0, 1/3. And remember, the undefineds are still undefined. Okay. All right. For the next one, this time we're multiplying on the inside. So what's going to change here is my x value because it's a horizontal shrink or stretch. In this case, it's a shrink. Negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. And let's see, we have undefined, negative 1, 0, 1, undefined. If you want to pause this video and go through and fill in all of your regular tangents, feel free. That might save you a little bit of time to just kind of run through it all real quick. All right. So what we are going to do here is multiply by the reciprocal. So the x column is going to get multiplied by 1/2. We're multiplying by the reciprocal here. So we still have y unchanging. Negative pi over 2 times 1/2 is negative pi over 4. Negative pi over 4 times 1/2 is negative pi over 8. Pi over 8s are going to be in between 0 and pi over 4s. 0 is still 0. That's going to be positive pi over 8, and that's going to be positive pi over 4. So this is going to shrink. So my first dashed line is at negative pi over 4. My last dashed line is at positive pi over 4. I still have the point 0, 0. Negative 1 happens at negative pi over 8, which should be here, halfway between 0 and pi over 4, and same thing over here. So it's really shrunk. You can almost see it's like, you ever seen in the old Star Wars where like the doors and the garbage chute start to like close in on them. So kind of the same thing. It's like those dashed lines are kind of starting to close in, or like you're pushing an accordion together. All right, so we have same idea here, but this time we're going to multiply by 1/3. This might be a little messy to graph here. It would have been nicer to have maybe some easier numbers, but that's okay. We'll still have undefined. We'll still have negative 1, 0, 1. And now we're just multiplying the x column by 1/3. So that'll be negative pi over 6. Negative pi over 12. We might skip graphing this one. This will not be fun. 0, pi over 12, and pi over 6. And you're going to see it's just really going to be messy. Negative pi over 6 would be somewhere around here-ish. somewhere around here. And then we'll still have 0, 0. And pi over 12 is going to be, I don't know, probably something like this. Really hard to do on a graph where those numbers just aren't going to show up. So it'll be something squished like that.